Hey everyone, so today we're going to review how to raise a monomial to a power. Okay, so let's work with exponents a little bit before we get into the real concept that today's focus is for today. So find each product. So 3 to the third power. So remember, that means 3 times. So 3 times 3 times 3. And when you multiply that, you get 27. For the second one, now we have x squared times x squared times x squared. So we are multiplying monomials here. So please don't forget, when you're multiplying, you add the exponents. So multiplying equals add exponents. So we are going to add these three exponents together. 2 plus 2 plus 2 gives us 6. So this is x to the 6th. Okay, part C. Now this is saying 3x squared to the third power. So just like up here when we did 3 to the third power, it was 3 times. So when we have 3x squared to the third power, it's this 3x squared 3 times. So I'm going to write that 3 times. 3x squared times 3x squared times 3x squared. Now this is very similar to what we just did in part B. So we're going to multiply our coefficients and we're going to add our exponents. So remember, coefficients, numbers in front. So we're going to multiply those together. We get 27. And then exponents, we're going to add those. 2 plus 2 plus 2 gives us x to the 6th. So I want you to notice something here. We have a 27 in part A. We have a 27 in part C. We have a x to the 6th power in part B. We have an x to the 6th power in part C. So basically, raising a monomial to the third power is you are raising both parts of that monomial to the third power. So just like here, I'm going to just show you. So notice 3x squared to the third is the same as 3 to the third, which is what we did in part A, and then x squared to the third, which is part B. And a quick way to do this, if you don't want to write it out 3 times, is what we did was this 3 here had an invisible exponent of 1. So what we did is 3 times 1 gives us 3, which is right here. And now 3 times 2 gives us 6. So this became 3 to the third, and then x squared to the third, which gives us 27x to the 6th. We're going to take a look at this a little more in depth on the next slide. When raising a monomial to a power, we can expand the monomial and multiply, which is what we did initially, or we can raise the coefficient to the power and multiply each exponent by the power. So this is called the power rule. So what you can see here is if we have a monomial raised to a power, we're going to take that coefficient and raise it to that power, and then we're going to multiply our exponents. So if this has a little invisible 1, treat it like you're distributing that exponent to those exponents. So this becomes c to the b power and then x to the a times b power. Let's take a look at some examples. So simplify the following. Here we have 4 squared to the third power. So we are going to multiply these exponents. That becomes 4 to the 6th power. Now we can simplify this because 4 is a number. We can raise it to the 6th power. That's going to give us 4,096. Say we didn't want to do that and we wanted to write this out 3 times for some reason. We could have written 4 squared 3 times. So 4 squared times 4 squared times 4 squared, which in this case you have to add your exponents. you would get 4 to the 6th, which would give you that 4,096. But I don't want to write this out 3 times. I want to use that shortcut because I know 2 times 3 is going to give us 6, which is going to give us the same answer in the end. Let's take a look at question number 2. So we have 7d to the 3rd. I'm going to include that little invisible 1 for both of these terms. And I'm going to distribute the 3 to both of them. So this becomes 7 to the 3rd power and d to the 3rd power, because 3 times 1 is just itself. Now from there we can simplify 7 to the 3rd power. That's equal to 343 d to the 3rd. Now if you didn't want to use this power rule, we can take a look. It's the same thing as if we write this 3 times. So 7d times 7d times 7d. Multiply your 7 3 times, you get 343. Add your exponents for that variable d, and you get d to the 3rd. So it's the same answer, 2 different methods. Same thing, same answer, 2 different methods. Now let's take a look at question number 3. This is pretty long. We have negative 5x squared, y to the 4th, to the 5th power. I do not want to write this out 5 times. This is too much. Sometimes they're going to have you raise something to the 10th power or the 15th power where you don't want to have to write that out 10 times. So that's where that power rule really comes in handy. So I'm going to put my invisible exponent of 1, and I'm going to multiply my exponent on the outside to all of the exponents on the inside. So that's going to give us negative 5 to the 5th power. Then we have x to the 5 times 2 is going to give us to the 10th power. And then y, we have 5 times 4 to the 20th power. Now the last step is simplify that number raised to the 5th power. Now this is negative. A negative number raised to an uneven exponent is always going to be negative. And then 5 to the 5th power is 3,125. And I'm going to just rewrite my x to the 10th, y to the 20th. And that's it. So like I said, I didn't want to write that out 5 times. So that's when I'm going to use the power rule. If it's something like this where it makes more sense to you if you write it out, that's fine. And you can use whatever method works for you, but the power rule is really a quick way when you have larger exponents. Now, the one thing I really don't want you to forget is raising this coefficient to the exponent. So a lot of students forget that you have to raise that 7 to the 3rd power and that negative 5 to the 5th power. That's why I like to include that little invisible 1. So you're treating it like you're distributing the exponent, to keep that in mind, because that's a really important part of this.